If you've ever gone through Windows 11, carefully turned off ads, disabled suggestions, reduced tracking, and customized your system for privacy, there's a frustrating pattern that many users keep running into. After a major update, some of those settings appear to change again. Features that were switched off seem active once more, and in some cases, the system looks almost identical to how it was before you made any adjustments. That creates the impression that Windows is undoing your choices without asking, and for many users, it happens right after a feature update or cumulative patch. This issue has been discussed repeatedly across user forums, IT communities, and technical support threads over time. People install updates normally, restart their systems, and everything appears stable at first. But later, subtle changes begin to appear. Personalized recommendations show up again in the Start menu. Lock screen tips return after being disabled. Privacy dashboards show different toggles than before. In some cases, even app suggestions inside settings or search results reappear after being previously turned off. From the user side, it feels like settings have been reversed, even though no manual change was made. At the same time, it is important to note that not every user experiences this consistently. Some systems retain settings perfectly across updates, especially when configurations are simple or when fewer optional features are disabled. This inconsistency itself adds to the confusion because it makes the behavior feel unpredictable rather than systematic. To understand why this happens, it's important to look at how Windows 11 updates actually work under the hood. These updates are not simple patches that only fix bugs. They often replace parts of the operating system itself, including the Settings app, background services, feature flags, and configuration templates. When Microsoft pushes a feature update, it may introduce redesigned versions of existing components, and those new components sometimes rely on updated default configurations. If a setting has been moved, split into multiple options, or replaced entirely, Windows may temporarily apply a default state until the system fully aligns with the new structure. Privacy and personalization settings are where most of the confusion becomes visible. Windows 11 includes multiple layers of data handling, including required diagnostic data and optional diagnostic data. Required data supports system stability, security updates, and hardware compatibility, and it cannot be fully disabled in consumer editions. Optional data is what users typically reduce when they want less tracking or fewer personalized experiences. However, when updates restructure how these systems operate, optional settings can be reinterpreted or migrated into new categories, which creates the appearance that tracking features have been turned back on. Another important factor is the difference between cumulative updates and feature updates. Cumulative updates are smaller, frequent patches focused on security fixes and reliability improvements, and they usually do not cause visible configuration changes. Feature updates, however, are much larger system upgrades. They can introduce redesigned interfaces, new services like Copilot integrations, and changes to how system components communicate. During these upgrades, Windows may rebuild configuration layers. When that happens, older settings do not always map cleanly onto the new system design, which can lead to temporary fallback defaults being applied. A concrete example of this is the Start menu experience. In some updates, users report that recommended apps or suggested content reappears even after being disabled. This is not necessarily a manual reactivation of a single toggle. Instead, the Start menu system may have been rebuilt with a new recommendation engine, which reintroduces default behaviors until personalization settings are reapplied correctly. A similar pattern has been observed in lock screen suggestions and search highlights, where underlying services are reinitialized after system upgrades. A big part of the issue also comes from how Windows 11 is evolving toward more experience-driven features. The operating system is increasingly tied to suggestions, recommendations, cloud-connected personalization, and AI-powered tools. Features like Start menu suggestions, lock screen tips, app recommendations, and integrated assistant functions rely on multiple interconnected background services. When updates modify how these services interact, Windows may re-enable supporting components to ensure the system functions correctly. From Microsoft's perspective, this reduces feature breakage after upgrades. From a user perspective, it can feel like previously disabled behavior has returned without consent. There is also a technical process happening in the background involving policy re-evaluation. When Windows installs a major update, it rebuilds parts of the registry structure and reapplies configuration policies. If a setting is considered outdated, deprecated, or replaced by a newer version, the system may override it with a default configuration tied to the updated design. This is not always visible to the user because Windows does not present a detailed breakdown of every policy change during upgrades. Instead, changes are absorbed into the system silently, which contributes to the perception of unexplained resets. Cloud synchronization adds another layer of complexity. Windows 11 increasingly connects local settings to Microsoft account data, especially for users signed into multiple devices. After an update, when the system reconnects to cloud services, it may reconcile local preferences with stored configurations. If differences are detected, Windows may prioritize the cloud profile or updated system defaults depending on the category of the setting. This can lead to certain preferences appearing changed even when the user did not manually alter anything. Another reason users notice these changes more now is because Windows itself is actively evolving at a faster pace than earlier versions. Settings are not static anymore. Microsoft has been redesigning the Settings app, moving options between menus, splitting older toggles into multiple controls, and introducing AI-related features that depend on continuous background services. When a setting changes location or definition, the system may temporarily reset its state during migration. That migration process is one of the most common hidden reasons behind post-update configuration differences. It is also important to understand that Microsoft does not describe this behavior as deliberately overriding user choices. From their standpoint, updates are designed to maintain system stability, security, and compatibility across a wide variety of hardware configurations. In some cases, preserving every previous configuration exactly as it was can create conflicts with new system components. So instead, Windows prioritizes functional defaults that align with the updated architecture. The trade-off is that some user preferences may not carry over seamlessly during transitions. Enterprise systems behave differently, which helps explain why this issue is often more visible in consumer environments. In business deployments, administrators can enforce strict policies using management tools, preventing settings from being altered during updates. These systems are far more stable in terms of configuration persistence. Consumer editions of Windows, however, prioritize flexibility and feature delivery, which gives updates more freedom to adjust settings when necessary. What makes this issue more noticeable today is the direction Windows 11 is heading overall. The operating system is becoming more tightly integrated with cloud services and AI-driven features. That means more background connectivity, more dynamic configuration models, and more frequent updates to how features are delivered. As a result, settings behave less like permanent switches and more like adaptive states that must align with evolving system requirements. Another factor that often goes unnoticed is how Windows handles recommended defaults after major updates. When a feature upgrade installs, the system may run a configuration evaluation pass based on hardware capability, region settings, account type, and usage patterns. Based on this analysis, Windows applies what it considers optimal defaults for the updated system. In some cases, this can re-enable features that were previously disabled if the system determines they improve compatibility or usability in the new environment. There is also the issue of background service dependencies. Many Windows features are not isolated toggles. Disabling a visible setting does not always stop all related services if other system components depend on them. When updates modify those dependencies, Windows may restart or reinitialize services that were previously inactive to maintain system stability. This can create visible behavioral changes even when the original setting appears unchanged at a surface level. From a user perspective, The most frustrating part remains the lack of transparency around these changes. Windows does not provide a detailed item-by-item breakdown of configuration changes after updates. Instead, most information is buried in high-level release notes or technical documentation that does not explicitly map to user-facing toggles. This makes it difficult to determine whether a change is intentional, structural, or a side effect of an update process. This lack of visibility leads many users to adopt a routine post-update check. After every major upgrade, they manually review privacy settings, personalization controls, background permissions, and system recommendations to ensure nothing has shifted unexpectedly. Over time, this has become a standard habit among advanced users rather than an occasional precaution. This behavior itself reflects a broader pattern. Even when changes are technically justified by system redesigns or compatibility requirements, users still experience them as instability. That perception of inconsistency becomes the core issue, especially for users who expect long-term persistence of manual system configurations. At the end of the day, what users experience as Windows re-enabling everything is usually not the result of a single intentional switch being flipped back by Microsoft. Instead, it is the combined outcome of multiple system processes interacting during and after updates. Windows updates replace core system components, reinitialize configuration layers, and integrate updated services. At the same time, cloud synchronization may reapply stored preferences, while feature updates introduce new defaults designed for redesigned system architecture. On top of that, Windows applies default profiles during upgrades, runs policy re-evaluation processes, and ensures that new features have the necessary background services enabled to function correctly. These mechanisms overlap, creating a situation where settings appear to have been reversed, even though the system is actually rebuilding its configuration under a new framework. The combined effect is a system that feels increasingly dynamic rather than static. And as Windows 11 continues evolving toward deeper cloud integration, AI-driven functionality, and continuously updated system components, the gap between user expectation and system behavior